Here are answers to the inequalities and interval notation test. I'm not sure if this is in focus, so I'm going to read every problem before I do it. This is it says solve the inequalities for these first 6 problems here. And alright, it says 2x plus 4 is less than 3x minus 1. So with all these linear problems where there are no squares, there's no x squared terms, you want to get all the x terms on one side and get all the non-x terms on the other side, and then just basically solve for x. So I'll subtract 2x from both sides, and I'll add 1 to both sides, and that'll give me 3x minus 2x is just x, and 4 plus 1 is 5, and the answer is right there. It's 5 is less than x, or x is greater than 5. In interval notation, it would be 5 to infinity. Get a different pen here. Number 2, it says negative 3 is less than 5x plus 4, which is less than 6. So again, I'll just solve for x, subtract 4 from all 3 sides. So 3 minus 4 is minus 7, is less than 5x, is less than 6 minus 4 is 2. And then just divide all 3 pieces by 5, and you'll get minus 7/5 is less than x, which is less than 2/5, which is another way of saying that x is between minus 7/5 and 2/5. So in interval notation, that would be minus 7/5, all numbers between that and 2/5. Alright, this third one, it says x squared plus 2x plus 5 is greater than or equal to 8x minus 4. With all the quadratic ones, you're always going to want to have everything multiplied out just like this, and bring everything on one side so that there's a 0 on one side of the inequality. And if possible, try to get a positive coefficient by the x squared. So the coefficient's already there. We just need to bring the 8x minus 4 over to the other side, and that'll give us x squared. 2x minus 8x is minus 6x. 5 plus 4 is plus 9, greater than or equal to 0. And then we try to factor this or find the zeros, so we can plot it on a number line and maybe pick some test points and figure out the answers. But this factors into x minus 3 quantity squared is greater than or equal to 0. Now the one way that you could do this is to just notice that whatever number x is, all that we're going to do is subtract 3 from it and then square the answer. Now anything squared must be at least 0, because you can't get negatives out of you can't have negatives as an answer when you square things. So the quick way to do it is just to see that the answer is all real numbers. No matter what we plug in for x, the result is going to be squared, and the result of that is going to be greater than or equal to 0. Or we could do the same, treat it like we usually do by drawing out our number line. We mark down where it's 0, and we see at 3 the value is 0. 3 makes it 0. And if you plug in a number greater than 3, the result is going to be positive because the argument's positive and you square it. And if you plug in a number less than 3, the same thing applies. The argument will be negative, but you're going to square it in the end anyway, making it positive. So again, the solution set is all real numbers. Alright, number 4. That says x squared minus 3x is less than 6 plus 2x. So we're going to bring the right-hand terms on over to the other side, and that'll give us x squared. Let's see, minus 3x minus 2x is minus 5x. Minus 6 is less than 0. And this factors into x minus 6, x plus 1 is less than 0. So what we do with these is we draw out a number line, mark the numbers that make it 0. So if x is negative 1, the value is 0, and if x is 6, the value is 0. And if we plug in a number greater than 6, both factors are positive, and we get positive numbers. If we plug in a number between minus 1 and 6, that'll make this term positive, but this term is negative, because we're less than 6, but this term is still positive, so their product is going to be negative. And if x is less than minus 1, both factors are negative, so their product is positive. So we want the numbers that are between minus 1 and 6, because that's where we want less than 0. So the solution is x is between minus 1 and 6, and if you want it in interval notation, minus 1, comma 6. Number 5, rational inequality. We treat this much in the same way that we treat the quadratic ones, and instead of two numbers being multiplied, in the end we have a quotient of two things being divided. Let me write this out: 2x minus 5, so you can see it. X plus 2 greater than 0. And so what we do is we find the numbers of values of x that make this expression 0, which in this case would be 5 halves. 5 halves makes it 0. And we see the values of x that make it undefined. So in this case, that'll be negative 2. Will give us undefined. So I can make an x to make sure we know that we can't plug in minus 2. And then we treat it like we treat the other problems. If we plug in a large number, both the top and bottom will be positive. Hence the quotient will be positive, so I write a plus. If x is between minus 2 and 5 halves, the numerator will be negative, and the denominator will be positive. So when you divide them, you'll get a negative number. And when x is less than minus 2, both the top and bottom will be negative, and so when you divide them, we'll get positive. And so the answers are, we want to know where is it greater than 0. So this expression will be greater than 0, provided that x is less than minus 2, or x is greater than 5 halves. And if you want it in interval notation, it would be minus infinity to minus 2, union with, or 5 halves to positive infinity. Number 6. 3x squared. 3x squared is greater than or equal to 12x. Well, I'll draw this out. So 3x squared greater than or equal to 12x. One thing to never do is to divide out an x from both sides of the equation. Never divide out an x, because you'll lose a solution if you do it that way. Be safe with variables. Take everything. Just use addition and subtraction. So take everything on the one side. We'll keep this over here because it's a positive coefficient already. So that'll be 3x squared minus 12x is greater than or equal to 0. And then just like we did with the one up top here, we factor it. All right, we factor it, and that'll give us 3x. X minus 4 greater than or equal to 0. And so we draw out our number line. So what numbers make this expression 0? That would be at 0 it's 0, and at 4 it's 0, right? The two factors. So if I plug in a number greater than 4, both this is positive and this is positive, so the product is positive. To this side of 4, this term will be negative because you're taking away 4. Times this is going to be positive, so that'll be negative times positive is negative. And then on the other side of 0, this term is negative because x is negative, and this term is negative because it's negative minus 4. So their product is positive, and since the question asks for greater than or equal to 0, we want numbers less than 0 or greater than or equal to 4. So less than or equal to 0 or greater than or equal to 4. To write that in the interval notation, it would be minus infinity to 0, union with, that gets a bracket because 0 is included, right? 0 makes it 0, so that counts as a solution. Union with 4 to infinity. These 3 at the bottom, circle the expressions which are written incorrectly or do not make sense. Let me zoom in on this so we can maybe see it better. Alright, so this one is incorrect because it has a bracket on the infinity, so that one's wrong. This one is incorrect because the infinity is to the left of 8 and the larger quantity always goes on the right, so that's incorrect. This means all numbers between minus 7 and 5, not including 5 but including minus 7, so that's okay. This one doesn't make sense because the larger quantity is supposed to go on the right, and the negative 10 is out of place. And this one means all numbers between minus 3 and 0, including minus 3 but not 0, so that one's okay, that makes sense. And alright, let's see if we can go through these other ones here on the back. Okay, it says convert the, well, let's see, okay. Convert from inequality notation to interval notation. So this means all numbers between minus 3 and 6, including minus 3 but not 6. So I say a bracket on minus 3, comma 6 with a parenthesis, and that's that. The second one says x is greater than or equal to minus 3. So that would be minus 3, comma infinity. Right? X can be anything greater than or equal to minus 3. And this third one here, x is less than 10 or x is greater than 20. So the way that we say x is less than, x is less than or equal to 10 would be minus infinity, comma 10. Put a bracket because it's included. Or means the union. And x is greater than 20, exclusively greater than, so 20 is not included, to infinity. Alright, these next few. That says rewrite the following sets using a single interval if possible, and if not possible, write OK. What I like to do is draw out both of these sets on a number line just to get a little bit of perspective. So between minus 5 and 0, I'll say that's minus 5 and that's 0, and that's all these. And then this is between minus 1 and 8, so minus 1 is in here and 8's out here. So that's all these. And since I'm taking their union, everything in both sets counts. So this counts, and all this also counts. And the way we say that is everything from minus 5 up until 8. Right. That's that one. This middle one. This is okay. All numbers between minus 25 and 10. So here's 10, minus 25, and this says everything from 0 to infinity. So here's 0. This is everything. So this is the top one is all these, and the bottom one is everything that's positive. Their intersection is the restrictive one. They're only going to be the numbers that are in, only the elements in both. So it's only these and only these. So the smallest number that is in both is up to but not including 0. So we write 0. And the largest number is up to but not including 10. So 0 to 10. Alright, this thing here. 0 to 5 union with 10 to 15. So 0 to 5 is like here somewhere, and 10 to 15 would be totally disjoint from it. So there is no overlap in these two sets. Here's 0, here's 5, here's 10, and 15. Since there is no overlap, and we're looking for a union, there's no way to break this up and write it as one set. So this is okay as is. That one we'll say okay. Alright, everything between 0 and 5, and everything between 10 and 15. There's no way to write that in one thing. So move on to the next. This is the same set of sets, right? The 0 to 5 and the 10 to 15, and because they don't overlap, they're intersect. They don't have. There is nothing. There are no items that are in both of these, so their intersection is the empty set, which we symbolize like that. Last one of these. This one on the left is all numbers between minus 8 and 8. Right. And that's intersected with all numbers between minus 4 and 4. So we're looking for numbers that are in both of these at once, and the only numbers they are between minus 4 and 4. So it's a proper subset of this. It's minus 8. So their intersection is just the set on the right. Everything between minus 4 and 4. Next is the graph one. You just might want to write these down. Well, here, let's see. we want g of x less than or equal to 0, and g of x greater than or equal to 2. And here's the graph of g. Alright, so for this first one, it says it's asking for the values of x that make g of x less than or equal to 0. So if you know how to read the graph, right, the x-axis is the x-axis and the y-axis is g of x. So the values of x that cause g of x to be less than 0 are between 0 and 2. Alright, because when x is in here, when x is any of these numbers, the output, the corresponding y's, the g of x numbers, they're all less than 0. They're down. Alright, this way is less than 0 on the g of x axis. So these numbers inside make g of x less than or equal to 0. And the other question says, where is, for what values of x will g of x be greater than or equal to 2? So same thing, you go back, you look at the graph, and you see where is g of x greater than or equal to 2. So on the g-axis, right, here's 1, 2. So anytime g of x, the points are above this, those x values are going to be the solution. So it's these x values back here, alright, because these cause the curve to be above 2. Here's the line 2. We want the graph to be above this line. And the numbers outside of here will also make it greater than or equal to 2. So that would be x is less than minus 2, or x is greater than 4. And for the first one, x is between minus 2 and 2. Alright, the last extra credit. Invent a quadratic inequality whose solution is between minus 5 and 12. Alright, well, if it's going to center around minus 5 and 12, when you factor it, let's see if I'll write it over here. Minus 5 and 12, it'll be x plus 5, x minus 12 is what? Is greater than or less than 0. Well, let's see, if we write out a number line, I'll say where is this going to equal 0, and it'll equal at minus 5 it'll be 0, and at 12 it'll be 0, and we want the numbers in between to be solutions for the inequality. So we just have to think, if x is in this region here, then everything is positive, so we don't want these as answers. If x is between minus 5 and 12, then one of the factors is going to be positive, that one, and the other factor is going to be negative, and so their product will be negative. So it's going to go like this, and if you test them out over here, both products will be negative, and so both factors will be negative, so the product is positive, so it'll be everything inside here, and so we would want less than or equal to 0 for that one. And the last one says solve this inequality. I'm going to rewrite this up here in the corner and show you how it's done. So it's x cubed minus 3x squared is less than 4x. I'm going to bring it all over to one side first. X cubed minus 3x squared minus 4x is less than 0. And show you how it's done. It's done basically the same way that we do the quadratic ones. You factor it, and what will this factor into? An x will factor out, and then from the remaining terms on the inside, that'll be what? We'll have x squared minus 3x. So we numbers that add to minus 3 and multiply to minus 4, that'll be x minus 4, x plus 1 is less than 0. And then we make one big number line, and on it we mark the zeros of this. Right? It's the same as any other quadratic one, only it's got 3 terms in it. So again, you plot which numbers make it 0. So if x is minus 1, it'll be 0. If x is 0 from this one, it'll be 0. And if x is 4, it'll be 0. And to keep it brief, I'm not going to do it, but if you plug in a number greater than 4, everything is going to be positive, so that'll be positive. And when every time we cross over one of these zeros here, another one of these factors is going to change sign. So when I cross over, so when I go from picking numbers in this region to picking numbers in this region, the sign of this second term switches from positive to negative. So that'll change the sign of the entire thing to negative. And that same process happens when we go over here. It switches another one, making everything positive. And back over here, in this region, all three terms are negative, so their product is negative. And since we're asked for where is it less than 0, the answers that we want are less than -1 or between 0 and 4. So to write it in interval notation, it would be from -infinity to -1, union with 0 to 4.